Question 1. If f of x equals the square root of 4x plus 7 and g of x equals 2x squared minus 5, find the composition of f composed with g. So when we're doing something like this, what we want to do is essentially substitute one function into the other. What this means is that we're going to substitute the square root of 4x plus 7 into 2x squared minus 5. So we have g of x is equal to 2x squared minus 5. And when we substitute this in, we're going to get 2 times the square root of 4x plus 7 squared minus 5. The square and the square root are going to cancel. So this will leave us with 2 times 4x plus 7 minus 5, which when we distribute through, we're going to get 8x plus 14 minus 5. And after doing some simple arithmetic, 8x plus 9. Moving on to problem number 2, we're going to find all the complex roots of the function f of x equals x squared minus 4x plus 36. So for this problem, we're going to use the quadratic formula, which states that the roots of an equation are negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we're going to remember what these actually mean. They're essentially the coefficients on these terms. So this is a, b, and c. So for this, we're going to substitute them in. We're going to go negative 4 is 4 plus or minus the square root of 4 squared is 16, or negative 4 squared is 16, minus 4 times 1 times 36 all over 2 times a, which is just 2. Now, this simplifies down to 4 plus or minus the square root of negative 128 all over 2. This term, the negative 128, can be simplified out, or expanded out rather. So 4 plus or minus the square root of negative 64 times the square root of 2 all over 2. And this term right here, since we have that negative 1 is equal to I, we can simplify this and get 4 plus or minus the square root of 64 times the square root of 2 times I all over 2. The square root of 64 is 8, so we get 4 plus or minus 8I times the square root of 2 over 2. Now we can divide out 2 from both of these terms to get 2 plus or minus 4I times the square root of 2. And so our complex roots of this function will be x is equal to 2 plus 4I times the square root of 2, and x is equal to 2 minus 4I square root of 2. And that's all I have for today. Thank you very much for watching.